we're going to take a more in-depth look at actually doing operations with rational numbers. So this is the set of our objectives for this lesson. So first I want to go back to that area model. The area model is really useful when I'm looking at circles or rectangles or some shape of a whole that I'm then going to divide into equal parts. Now, if I look at the area model, it's pretty clear that if I take 2/5 and I add another shaded region, I get 3/5. This is a great way to show students the initial part of adding fractions. If I'm doing the number line, this is slightly more advanced for your older learners, but you can still show them that if I take 2/5 and I go an extra fifth, that's going to put me at 3/5 on the number line. Now, from those examples, we would want to scaffold them. So let's show them a few examples using those methods. And then we want to ask them, well, what did we do? And hopefully they'll be able to find the pattern that they were just adding the top numbers. So if I have two rational numbers with the same denominator, I'm just adding the values at the top. So that's to say that if I have addition of rational numbers with unlike denominators, that's when I have a little bit of trouble. So when I do that, I have to find a common denominator. And so this is a shortcut for the common denominator that we can use with students. We can actually tell them to multiply the two denominators together. And when you multiply the two denominators together, you're going to get a common denominator. You have to make sure you multiply A times D and C times B before you add the numerators together. So what does that look like? So instead of trying to teach them to find the least common multiple, especially when we're first introducing this, I can say, all right, you've got 15 and you've got 21. I can do 2 times 21 plus 4 times 15, and then I can do 15 times 21 as my denominator. So it's, I believe this is typically called the butterfly method, and that's what they're usually referring to when they actually use that shortcut. Not everyone teaches the butterfly method, so it may be something that's not going to be in your curriculum. Now, what's shown in red is the traditional least common multiple method. So in that method, you're trying to get them to figure out, well, what's the smallest common multiple, which is 105? Well, then what would you have to multiply by to get 105? And so that's a little bit more of an advanced process than what we saw on the previous screen. In part B, I'm taking this and I'm saying, well, I'm doing 2 times 5 and 1 times -3 over that -3 times 5. This is the butterfly method happening. And that's how I get -7 over 15. So A is the traditional method we've taught. B is the quicker, more or less intense thinking process that we get with the butterfly method. So in part C, what I can do is I can do 3 times 5 because they're across from one another, 1 times 4, add those together to get my value. And then I just multiply the denominators together. And the beautiful thing about this, teachers, is that it works when we start introducing variables in algebra. So you might say, well, that's lazy. It's lazy of my students not to come up with the least common multiple. But the minute I throw x and y in there, look at how much easier this is. The 3 and the y are diagonal. The x and the 4 are diagonal. So I'm going to do 3 times y plus 4 times x. And then I just multiply the denominators. And I put it all in one fraction. That process of the butterfly method feeds into algebra perfectly. So it's not going to be a weakness showing them this butterfly method as opposed to the traditional one. And this is another example where I'm going to cross multiply here to work together to find a denominator that works. Now, mixed numbers are numbers that are made up of an integer and some fractional part. A mixed number is considered a rational number, so because that means it can be written as a over b. So if I want to change the mixed numbers to a fraction or a proper fraction, the idea is that 4 and 1/3 is really 4 plus 1/3. So really what I'm doing is 4 over 1 plus 1 over 3. And I'm going to take 4 times 3, butterfly method, plus 1 times 1, all over 3. Now wait a minute. Do you remember your grade school teacher teaching you to do 3 times 4 plus 1? Do y'all remember that? They were showing you the butterfly method without showing you the formal method. So when you did the conversion of a mixed number into an improper fraction, you probably never understood you were finding a common denominator because you were really adding two fractions. So this is taking an additional step forward in the process. The same thing is true in B. We can use that same butterfly method to get to the end game. And then after they've been successful with that butterfly method, then we might want to show them, we'll do 5 times 3 plus 2. But let's teach them to scaffold their learning first. Now, what if I want to go from an improper fraction to a mixed number? Well, if that's the case, then I've got to think about how many times does 5 go into 29? How many whole times? Well, it goes in there 5 times because 5 times 5 is 25. What's the remainder? The remainder is 4. So it's going to be 5 and 4/5. But I can also go in reverse from that method, the butterfly method, to get here. Now, the additive inverse is going to be similar to what we saw with integers. If I take a positive value and I add its negative twin, I get 0. That's the additive inverse. So here are some additional properties with those inverses. The negative of a negative is going to be a positive for integers. The same thing is true in rational functions. And in integers, if I put a negative in front of the parentheses, I distribute it to every value inside, which is also what I do in number 2. Now, the addition property of equality means if I add this same thing to both sides of the equal sign, it's equal. It's okay. The subtraction property of rational numbers shows us that if I have two fractions that are rational numbers and I subtract one rational from another, I'm going to get an answer that is rational. Okay? Even if you get a whole number is rational. So when I subtract rational numbers, I get a rational number. Now, if I want to keep equality, then I would have to subtract it from both sides of the equal sign. And I should recognize that the subtraction of a rational number is the same as saying plus negative. So think about if I had 5 minus 2. That's the same thing as saying 5 plus negative 2. That's what we're saying right here. And then I can use that butterfly method, just like I did with addition. It also applies to subtraction, where I'm taking the denominator, multiplying the denominators together, A times D, B times C. Here are some examples. So in this first one, I'm taking this and I'm looking at it from the traditional standpoint. Least common multiple is 8, get a common denominator, and I go from there. I could also do 5 times 4 minus 1 times 8 over 4 times 8. In part B, I want my students to convert a mixed number to an improper fraction before they do the subtraction. This is a new best practice that's come out in teaching. So before, we might have started teaching students to do 5 minus 2. We want them to go straight to the improper fraction, subtract the improper fractions, then convert it back to a mixed number because they're getting the procedures that we want. Here, I'm going to use the butterfly method. 3 times x, 2 times x, over 2 times 3. Look at how simple that becomes when I do it that way. And then this is the higher algebra when they start hitting middle school. This is what we're trying to teach them. So we're going to take each fraction and we're going to factor out what we can. Well, I can factor a 3 from my denominator and cancel out those 2 minus x's, and it gives me 1/3. And the second one, I can factor out a 2, and I can cancel out those x minus 2's, so I have negative 2/3. So this really becomes 1/3 plus negative 2/3, which is really negative 1/3. I have to have the caveat that x cannot equal 0 from the simplification that I did, because I'll get 0 in the denominator. In part C, look at this. I have similar idea, but I have two different polynomials in the denominator. So I'm going to cross them. I'm going to do the butterfly method. And then I'm going to simplify things. And then I'm going to cancel what I can. And when I combine those like terms, I have 2a minus 2a. So they cancel out completely. And then negative 2b and negative 2b becomes negative 4b. Here's another example where I'm building that algebra up. I'm going to butterfly method it. I'm going to simplify it until I get my final answer. Estimation with rational numbers is used pretty often because I don't always know what something like 5/12 is. That's hard to kind of conceptualize. So we use estimation a lot with rational numbers. And it plays a role in trying to judge, is this really a reasonable comparison? So here's an example of a sixth grade class that's collecting cans to go to the recycling center. And they brought these amounts of what's happening. How many pounds do we have together? So the first person, I have 1 1/8 pound, 3 4/10 pounds, 5 7/8 pounds. I want to add all of these together. So I can use front end estimation to try and figure this out instead of trying to take all of these values, convert them to improper fractions, add them together, convert them to a mixed number. I can just kind of estimate here. So if I'm looking at the front end estimation, that's 1 plus 3 plus 5, and that's going to be 9. The adjustment here is I know that I was off by a couple of values, and I'm going to say that's about off by 2. So when I add them together, I'm going to get 11, and that's going to be what I adjust that front end estimate to be. So here, I'm going to do the same thing, and I'm going to estimate 27 over 13 is almost 2, 10 over 9 is almost 1, so when I add them together, I get roughly 3. So you're almost trying to go to the nearest whole number. 3 9/10 is almost 4. 2 7/8 is almost 3. And then I have 11 over 12, which is almost 1. So if I estimate this, I'm going to get 8. So roughly estimating by whole numbers is what we're talking about with front end estimation.